The 2026 USS Zumwalt DDG-1000 remains one of the most futuristic and controversial warships ever built. From its stealth-inspired appearance to its advanced combat systems, this destroyer continues to capture the imagination of naval enthusiasts, military analysts, and technology fans around the world. At first glance, the ship looks less like a traditional naval vessel and more like something straight out of a science fiction movie. Its distinctive angular hull, smooth surfaces, and pyramid-shaped superstructure are all designed with one primary goal in mind: reducing radar visibility. Unlike conventional destroyers that feature numerous antennas, protruding equipment, and vertical surfaces, the Zumwalt was engineered to appear much smaller on enemy radar systems, making detection and tracking significantly more difficult. This stealth-focused design represents one of the most ambitious naval engineering projects ever undertaken by the United States Navy. Measuring approximately 610 feet in length and displacing around 15,000 tons when fully loaded, the USS Zumwalt is considerably larger than many destroyers currently in service. Despite its massive size, the vessel was designed to operate with a remarkably small crew thanks to extensive automation throughout the ship. Advanced sensors, computerized monitoring systems, and automated maintenance technologies reduce the need for hundreds of sailors performing routine tasks. This not only lowers operational costs but also improves efficiency and allows crew members to focus on mission-critical responsibilities. Walking through the ship reveals a highly modern environment filled with digital workstations, touchscreen controls, and integrated command systems that resemble a high-tech operations center more than a traditional naval vessel. One of the most impressive aspects of the USS Zumwalt is its integrated power system. Unlike traditional warships that separate propulsion and electrical generation, the Zumwalt uses a fully integrated electric power architecture. Massive gas turbine engines generate electricity that powers everything on board, including propulsion motors, sensors, weapons systems, and future technologies. This design provides exceptional flexibility and creates a foundation for integrating next-generation weapons that require enormous amounts of electrical energy. As naval warfare increasingly moves toward energy-based systems such as high-powered lasers and electromagnetic weapons, the Zumwalt's power generation capability positions it as a valuable test platform for future innovations. When discussing performance, the USS Zumwalt delivers impressive capabilities. The destroyer can reach speeds exceeding 30 knots while maintaining excellent stability across a variety of sea conditions. Its unique tumble-home hull design, where the sides of the ship angle inward as they rise above the waterline, contributes to its stealth characteristics while also creating a distinctive visual profile. Although this unconventional hull design has sparked debate among naval experts regarding behavior in extreme sea states, extensive testing and operational experience have demonstrated the vessel's ability to perform effectively in real-world maritime environments. The advanced propulsion system ensures smooth operation, reduced acoustic signatures, and enhanced fuel efficiency compared to many conventional warships. At the heart of the ship's combat capability lies a sophisticated suite of sensors and command systems. The destroyer utilizes advanced radar technology, electronic warfare systems, and integrated battlefield management software that allows commanders to process enormous amounts of information in real time. Modern naval warfare depends heavily on situational awareness, and the Zumwalt was designed to excel in this area. Information from sensors, aircraft, satellites, and other naval assets can be combined into a comprehensive operational picture, helping commanders make rapid and informed decisions during complex missions. This level of integration enhances survivability while improving the effectiveness of offensive and defensive operations. The ship's armament is equally impressive. The USS Zumwalt features an extensive vertical launch system distributed around the perimeter of the hull. These launch cells can carry a variety of missile types, including long-range land attack missiles, anti-ship weapons, and air defense interceptors. This flexibility allows the vessel to adapt to different mission requirements, whether supporting ground forces, defending naval task groups, or engaging enemy surface combatants. The distributed placement of launch cells also improves survivability by reducing the risk that a single attack could disable the ship's entire missile inventory. Originally, the Zumwalt class was designed around two advanced gun systems capable of firing specialized long-range precision-guided projectiles. These weapons were intended to provide naval gunfire support at unprecedented distances. However, the extremely high cost of ammunition eventually led to significant changes in how the Navy planned to utilize the platform. As a result, the focus has shifted toward missile-based strike capabilities and future advanced weapons integration. In the 2026 configuration, discussions surrounding hypersonic weapon deployment continue to generate excitement. The Zumwalt's large internal volume, substantial electrical capacity, and flexible architecture make it an ideal candidate for hosting emerging long-range strike systems that could dramatically expand its combat effectiveness. A major strength of the USS Zumwalt is its adaptability. Many military platforms are designed around fixed technologies that become difficult to upgrade over time. The Zumwalt, however, was created with future growth in mind. Modular systems and advanced digital infrastructure allow new technologies to be incorporated more easily than on many older warships. This flexibility helps ensure the vessel remains relevant as threats evolve and military requirements change. Whether integrating new missile systems, enhanced radar technologies, electronic warfare capabilities, or directed energy weapons, the Zumwalt serves as a bridge between today's naval capabilities and tomorrow's battlefield innovations. The ship also excels in electronic warfare and cyber resilience. Modern naval combat extends far beyond missiles and guns. Electronic attacks, communication disruption, radar jamming, and cyber threats have become central components of military operations. The USS Zumwalt incorporates sophisticated electronic warfare systems designed to detect, analyze, and counter hostile signals. Advanced cybersecurity measures protect critical shipboard networks and operational systems from digital attacks. This layered approach enhances survivability and ensures the vessel can continue operating effectively even in highly contested environments. Another notable feature is the destroyer's aviation capability. The flight deck and hangar facilities can support multiple helicopters and unmanned aerial vehicles. These aircraft significantly extend the ship's operational reach by providing reconnaissance, surveillance, targeting support, search and rescue operations, and anti-submarine warfare capabilities. As unmanned technologies continue to evolve, the ability to deploy and manage drones from naval platforms becomes increasingly important. The Zumwalt's aviation facilities position it well for future integration with advanced autonomous systems that can gather intelligence and support combat operations far beyond the horizon. The living conditions aboard the USS Zumwalt also reflect its modern design philosophy. Crew accommodations were developed with greater attention to comfort, efficiency, and quality of life than many previous generations of warships. Automated systems reduce repetitive manual labor, while digital technologies streamline administrative tasks and operational workflows. Improved habitability contributes to crew morale and readiness, especially during extended deployments. Although military service at sea remains demanding, the Zumwalt demonstrates how advanced engineering can improve the daily experience of sailors while maintaining combat effectiveness. One aspect that continues to generate discussion is the ship's cost. The Zumwalt-class program became one of the most expensive naval development efforts in modern history. Research, design, and construction expenses significantly exceeded original projections, leading to a reduction in the number of ships ultimately built. Critics argue that the program's high costs limited fleet expansion and created challenges in balancing innovation with affordability. Supporters, however, point out that groundbreaking